Hi, so we are in section 8.3. This is part 2. What we would just, a result we were just discussing in the previous video was that if we increase the sample size, then the confidence interval width decreases, okay? And if we decrease the sample size, then it also is the case that the width of the interval increases. Okay, so what we want to do now is discuss how we can use that relationship, right? There's the n and there's the half the width of the interval, the margin of error. So how can we use this relationship to help us design an experiment? So if we wanted to have, we want to set up an experiment and we want to determine a sample size, we have to determine a sample size. Now, it would be great to have very large sample sizes, but the truth is for every additional subject that you let into the sample, it's increased cost and increased time. So funding organizations usually want to understand why the sample size is what it is. How does that meet our requirements in terms of margin of error? So we can think of margin of error as how precise do we need our estimate of mu to be, okay? So if we need it really precise, that means we're going to have a small margin of error. Okay, so what often occurs then is that we have a desired margin of error and we need to determine a sample size. So I'm just going to do a little bit of algebra, and if you're not like that doesn't make you happy, you don't have to follow along or take notes on this piece, because the formula I'm deriving, which is going to be sample size for a given margin of error, is on the formula card. But I just thought we'd have a little fun. So, okay, so we want to solve for n. We want to isolate n. We're going to multiply both sides by the square root of n. So we have the square root of n e on this side, and over here, square root of n clears, okay? So what we did was just multiplied by the square root of n. Okay, now we're going to divide both sides. In order to isolate the n, we're going to divide both sides by e and then square, okay? So the square root of n is equal to z sub alpha over 2 times sigma divided by margin of error. And now we're just going to square both sides, and that'll give us the formula. I'll just put it here. N is equal to z sub alpha over 2 sigma divided by margin of error. Okay, squared. So this is the result, and this is available on the formula card under chapter 8. It's the third one down on the left column. So make sure you can put your finger on that. All right, so what we're going to do is we're going to use this relationship here to help us determine a sample size needed for an experiment. So back to the notes. Oh, yes, I'm sorry on the notes. We do clarify that since n is an integer, right, where it's a sample size, it's got to be 1, 2, 3, 4, 5. This is not. This is going to be, in general, a decimal number. And so you have to round up, because if you round down, then your confidence interval will be just a little bit too big. So we have to always round up, even regardless of what that decimal component is. We round up to the nearest integer. Okay, so we're gonna just have it, we'll go through the example in the notes. age of a civilian labor force. And please get out your calculators. That's what we're doing. This will be a calculation intensive. You might as well practice because it's a little different. Okay, so here's our formula that we're going to work with. But we'll go ahead and read first. Determine the sample size required to ensure that we can be 95% confident that mu is within 0.5 years of the estimate X bar. Sigma is known to be 12.2 years. Okay, so let's go ahead and kind of write down what we have here. We see that we want, that the confidence level is 0.95. That's in the first sentence. And we can be 95% confident that mu is within 0.5 years. So that's what they're giving us. That's how they're giving us their margin of error. So we want E to be equal to 0.5. And we know we're given in the problem that sigma is known to be 12.2 years. Okay, these are all in years. So we're asked for the sample size, find the sample size required so that this ends up being what we need. So we're going to use the formula. Put it up here. And that is N is equal to E sub alpha over 2 times sigma over E, and that whole quantity squared. Okay, so let's look at what we have in our problem. We have N is what we're looking for. Well, we need Z sub alpha over 2. We don't have Z sub alpha over 2. We have the confidence level, but we can sweep. So let's go ahead and sweep here. And I'm going to let you guys do that, okay, as an exercise. But it's also in the notes. So the 0.95 always sweeps through to the 1.96. So we have that. So the Z sub alpha over 2 is 1.96. Sigma, 12.2. And the error, allowed margin of error is 0.5. And then we're going to square that whole thing. Okay, so just make sure you use your order of operations, do the multiplication in the numerator, divide by 0.5, and then square. Okay, and we get, so 2,287.13, but you're going to round up, even though that decimal, if you were just rounding, you would just go to that number. But because this is a sample size problem, we have to round up so that the required N, the required sample size is 2288. All right, so that's it. And I'll see you in the next video.